to really be good at forensics, you have to actually be pretty good at Photoshop. You have to spend a fair amount of time in Photoshop making forgeries and understanding the techniques that a really good forger uses to make very compelling fakes. The way we think about forensics is we develop a series of tools, and each one of them can detect a different form of tampering. There's no silver bullet. There's no just push a button, tell me if it's real or not. We're not there yet. We're not even 10 years out. But we have a pretty sophisticated set of tools that can be used by a forensic analyst to spend time and look at an image. We are not at the stage yet, however, where you can, for example, analyze 10,000 images, in a day. So, for example, AP and Reuters both deal with roughly 10,000 images a day. We can't process that many images automatically. 5-10 years from now, maybe we can, but we're still getting there.
You're defeating the terrorists where they live and plan, and you're making America safer.
From this image, you wanted to clone something out of the background. You typically would take another part of the image, copy it, and paste it in. And we have a tool that can detect that. We have another tool that can look at the reflection of the light in your eye and tell where the light was from the little white specularities that are reflections of light in your eye. We have another tool that can tell you whether something's been enlarged or shrunk or rotated, which is a typical manipulation when you want to create a composite of two things. And sort of the list just goes on and on and on. And there's a whole bunch of sort of bags of tricks, basically. You just have a whole bunch of tools. And, each one is maybe applicable in 10% of the cases.
Bridge to Captain Kirk.
Yes, Mr. Barris, what can I do for you?
Kirk, this station is swarming with Klingons.
I was not aware, Mr. Barris, that 12 Klingons constitutes a swarm.
Doctored video is about where doctored photographs were 10 years ago, which is that it was possible to do, but it was hard to do it well. And doctored video is still pretty hard to do well.
So are you enjoying yourself in our nation's capital, young man?
I mean, sure, if you have a video that's 3 seconds long, so, a couple hundred frames, that's easy to manipulate. But take a standard video, 24 frames a second, and now imagine a 5-minute video. You're talking about tens of thousands of frames. And, the tools are getting better and better and better, but it is still very, very difficult to create very compelling doctored video. I mean, you only have to look at Hollywood at this, multi-million-dollar, hundreds of people on a set, to do a couple of short scenes. So I think it is possible, certainly, to doctor video. It is non-trivial, however, but the tools are going to be developing to make it easier and easier and easier. So we do have an initiative in my lab to detect doctored video. It's much to my surprise, it was harder than I thought it would be, in large part because you have so much data. So any computer program you write has to be incredibly efficient to be able to analyze tens of thousands of frames. So a lot of the things that we did for images turned out not to map very nicely to video, because you can spend a couple minutes analyzing an image, but you can't spend a couple of minutes analyzing one frame out of tens of thousands. It's not realistic. And so we're in this sort of spam, anti-spam, virus, antivirus game. We develop forensics techniques, and every year or so there's a new version of Photoshop and new video editing tools and new audio editing tools and higher resolution digital cameras and better PCs, and so there's this bit of an arms race going on. And it will end the same way all these things end, is that you make it hard as a forensic scientist to doctor video, images, documents, and audio, but you don't make it impossible.